Hello, my name is Jessica Rayson and I am an IOP coach based in Cambridge. This video is part of a series looking at the teaching of electricity in schools, and this video is looking at the factors that affect the resistance of a wire and how we can investigate those. In previous videos, we have looked at the relationship between current and resistance. We know that as the resistance of a circuit increases, the current decreases, as nicely demonstrated by this PhET animation. So why is that? Resistance is essentially a measure of how difficult it is for the charge to flow around the circuit, how much that charge is going to be opposed. Resistance is caused by the collision of electrons into ions. So what factors might make it more difficult for the charge to flow around the circuit? What might be increasing those collisions and hence increasing that resistance? When thinking about which factors affect a quantity, I like to give students a variety of factors for them to consider and ask them to pull out those that they think might have the biggest impact and to explain why they think that. One of the factors that students first come across is temperature. The ions in the metallic lattice of the wire are always vibrating about a fixed position. When electrons are moving along the wire, they collide with ions. This causes the ions to vibrate more, increasing the temperature, the likelihood of further collisions, and the resistance of the wire. There are three further physical factors that we will look at in this video: the material of a wire, the thickness or diameter of a wire, and the length of a wire. Firstly, charged particles will flow differently through different materials due to a property called resistivity. Copper has a lower resistivity, hence we use it for the wiring within our houses. Nichrome has a higher resistivity, so we use it when we need a heating effect, for example in a heating element. Resistivity is a property of material and is associated with the density of the delocalized electrons and the size of the metallic ions. The second factor is the thickness of a wire. The thicker a wire is, the easier it is for the current to flow. You can relate this to a student's experience by using straws. If they've got a nice big thick straw, it's a lot easier to blow down this thick straw than it is to blow down this thinner straw. Essentially, there is more space in this wire for my breath or the electrons to move through. There's going to be less collisions happening and therefore lower resistance. You can also compare this to corridors around your school. So for example, a wider corridor is going to be easier for students to go through than a thinner corridor. Lastly is the length of a wire. The longer a wire is, the more collisions those charged particles will have with those metallic ions as they're going along the length of that wire. You can bring out that analogy of straws again. Much more difficult to blow through the longer straw than it is the shorter straw. That's because there is more distance for that, for my breath or that charges to go, and therefore there are more collisions happening sort of on the way. Again, you can be using corridors as an analogy as well. Is it easier to go down a longer corridor or a shorter corridor? Investigating the resistance of a wire is a common practical in schools. It's often done with a long meter rule, so it's easy to measure the length, and with the wire that you're investigating taped securely along it. Firstly, let's look at investigating how the resistance changes with a changing length of wire. So for this, we've got a piece of Constantan wire secured across a meter rule. We've got that length of wire in series with batteries and an ammeter. So look at where the wires are connected in here. So that would be a current. We're using the bottom scale here. Oh no, sorry, the top scale. We're using the top scale here. So that is a current of about 0.25 amps going through that. Then we're going to be measuring the potential difference across different lengths of wire. So here at 10 centimeters, we've got potential difference of about 0.1 volts. At 20, it's about 0.5 0.4 volts. At 30, it's about 0.6 volts. And at 40, it's gone up to 0.9 volts. Then, after using voltage divided by current to calculate resistance, you can plot resistance against length, which should show that as the length increases, the resistance increases. Alternatively, you may be more familiar with changing the length of the wire each time using a flying crocodile clip. This setup has a few issues as the current changes as you change the length of the wire. If you are using this method, I would avoid test wires shorter than 30 centimeters long, as the resistance is low and the current increases to the point where there is heating issues. Also, you may find voltage dropping as the current increases, which is caused by the higher energy losses due to the internal resistance of the battery. However you do it, this whole practical can be repeated using a different thickness of wire. A thinner wire should have a steeper gradient or higher resistance, and a thicker wire should have a shallower gradient. Or it can be repeated using a different material, but take care with any low resistance wire to avoid heating effects. You can get a similar result to this practical using just a 6B pencil, a multimeter, a piece of graph paper and a ruler. Firstly, I make a nice thick line in 6B pencil along the x-axis. I set the multimeter to measure resistance. And then I'm going to measure the resistance of different lengths of line and mark them up on the graph. So looking along the length of the x-axis, I can see here that the resistance of this line goes up to about 140. So I'm going to go up in 20s on my y-axis. And then starting at the shortest and working my way up. So you should get a graph which looks like this, a nice straight line showing that as the length of the line or the wire increases, the resistance increases. With a different thickness of line or a different type of pencil, you'd get a different gradient. So, in this video, we have looked at some of the factors that affect the resistance of a wire. These include the length, the thickness, the material of the wire, and the temperature of the wire. We do hope that it's been useful.